Hello everyone, this is the start of Unit 2 and this is all about trig functions. You should have had some of this stuff in your previous math class, the SOHCAHTOA, if that's ringing a bell, but we're starting from the very beginning. So, angle characteristics. In case you forgot, the vertex of an angle is this point right here. The vertex is the end point of a ray. So a ray is an endpoint on one end and then an arrow. And basically if you combine two of those rays, you get an angle and they're combined at that vertex point. Now, something new, every angle from here on that we draw, we're going to draw in something called standard position. That way we draw them all exactly the same every single time. With standard position, you're going to have an initial side and a terminal side. The initial side is the starting position, which will go in a very specific location when we draw it. And then the terminal side is where the angle ends after rotation. So wherever the angle ends after rotation. So when we draw these angles in standard position, we will draw them on the XY coordinate plane every single time. And your vertex will go at the origin. The initial side will always be along the positive x-axis. So every time I ask you to draw an angle from here on out, you'll draw it on the XY coordinate plane, vertex at the origin, and you'll put your initial side along the positive x-axis. So that's all this stuff here. Angles that are in standard position, vertex at the origin, initial side on the positive x-axis. Now, if you are drawing a positive angle, you're going to go up or counterclockwise. So positive angles are determined by a counterclockwise position. I like to think they go up because it's positive from the initial side. And if you want to draw a negative angle, then you're going to go down from your initial side. So negative angles go clockwise, or again, I like to say they go down from the initial side. So basically, if I was drawing this angle, clearly it's bigger than 90 but less than 180, and it's positive because I'm going up. But we're going to have to start doing labels because there's technically an infinite amount of angles represented here. I could have this angle, which I could call theta. So that's theta, if you forget. Kind of looks like a little circle with a swoosh, theta. And this would be a positive angle that's somewhere between 90 and 180. But if I wanted to, I could also say, hey, I'm talking about this angle here, which is negative because I'm graphing down. This is a negative angle that's bigger than 180, but less than 270. And I could call that something else. If you do like a capital B with a little tail, that would be beta. So we're going to have to start labeling with your directional arrows, super important now because it's going to determine if your angle is positive or negative, and we'll label them since technically there's more than one angle being represented here. I could also keep going around and around and around, and that's how I have the infinite amount of angles. Now, when I'm drawing these angles, do you see how I have this theta and beta, and they both come to the same terminal side? We call those coterminal angles. Coterminal angles. Two angles in standard position that have the same terminal side. So there's multiple coterminal angles there. Long story short, you're basically adding or subtracting 360 degrees for multiple angles. Like say this was 100 degrees, just to make it easy. If this is 100, I could add 360 more. That would be another coterminal angle. But that I could keep adding or subtracting 360 and I'll keep ending on that terminal side. All of those angles are coterminal angles. So it says draw theta is equal to 220 degrees and label this is theta prime. Theta, that little mark there means prime, theta prime. That just means that it's the second angle. And label theta prime as the angle that is coterminal. So if I'm drawing 220 degrees first off, I put my vertex at the origin and I put my initial side along the positive x-axis. Since it is a positive 220, I know I'm going up. You should also know that every quadrant is 90 degrees. So it'd be 90, 180, 270 would pull me here. So you kind of just like estimate, because we're not pulling out protractors anymore, but this is why labels are so important. My directional arrow is going up and ending at the terminal side. This is representing that it's the positive angle and not the negative one below. And you give it its label. Theta is equal to 220 degrees. It told me to also label theta prime as the angle that is coterminal. So the coterminal angle could be this one if I go the negative route. So I would say theta prime is equal to, now if this is 220, we know to get through the rest of a circle, it would be 360 minus 220. If I did 360 minus the 220, this part here would be 140, but since I'm going down, it would be a negative 140. Oops, negative 140. So 220 and negative 140 would be coterminal angles. Basically, I can plus minus 360 degrees for numerous coterminal angles. Usually we only do 2 because then it just starts getting sloppy in the picture. Now, a lot of times people get this coterminal angle mixed up with the angle on the next page, which is a reference angle. So coterminal angles can be any size, positive or negative, but the end goal is you basically find one angle and then you could add or subtract 360 multiple times and get multiple angles. Whereas reference angles on the next page, reference angles, basically I'm going to sum this up for you. Super important. They must be, reference angles must be positive. So coterminal angles can be negative. Reference angles must be positive and less than 90 degrees. So they are very different things. So if I say find the reference angle, it has to be a positive angle and it has to be less than 90 degrees. So that's why it says acute there. And it says if the angle at the left is 210 degrees, so this they're telling me theta is 210 degrees, find the reference angle. Here's the deal. When we start drawing these angles in standard position, you're going to hear me start to mention bow tie triangles. Since we start drawing this angle on the x-axis, anytime we finish drawing an angle at the terminal side, basically you envision like a little dot up here by this angle, and it's going to make a triangle with the x-axis that it's closest to wherever it ends. So I would drop and make a little right triangle right here. And the angle that you're trying to find for the reference angle is always the angle in that little triangle. And I'm going to call that, I know that's super tiny to see, but it should look like a little fish. That's alpha. Alpha is usually what we call the reference angle. The alpha, the reference angle, is found by just kind of visualizing whatever setup you have. If this whole thing is 210 and I just want this little angle right here, basically I don't want any of this, and all of that is 180 degrees. So alpha would be 210 minus that 180. So alpha is 30 degrees. 30 degrees. The whole bow tie triangle thing that I kind of mentioned, here's the scenario. If I'm drawing an angle, if I'm in quadrant 1, so everything's starting here, don't forget. If I'm in quadrant 1 with my terminal side, this is my triangle, and my angle, my reference angle is going to be by the origin. If I'm in quadrant 2, this is my triangle, right triangle, reference angles by the origin. 3 we just did. Again, right triangle, angles by the origin. In quadrant 4, the triangle would look like this. Notice, when all said and done, it kind of looks like a little bow tie. So you'll hear me say bow tie triangle. This is what I mean. When you're drawing your triangles, you will never go to the y-axis. Like if I draw something like this is my angle, say that's my angle right there. Don't ever draw your bow tie triangle to this y-axis. That's bad. You'll always draw your triangle down to the x-axis because you start at the x-axis, you always end at the x-axis, no matter what quadrant you fall in. And just in case you forget, this is quadrant 1, quadrant 2, quadrant 3, quadrant 4. 1, 2, 3, 4. So if you hear me say bow tie triangles, it's so that you draw your pictures correctly, which you'll have to draw your pictures to find your reference angles, and then we actually solve those triangles that are formed as well. So some examples, it says draw each angle and state the reference angle. We're going to call the angle theta and the reference angle alpha for practice. So if I'm drawing 150 degrees, first off, every single one of these, I could start with my vertex at the origin and my initial side along the positive x-axis. I could set them all up. Like if I had a rubber stamp, I could just stamp it, because every angle we draw is going to look like this to start, every single one. Everybody gets their initial side. Now, once I determine what my angle is, positive 150 degrees, I know since it's positive, I will be graphing up. And I kind of eye up where 150 is. If every quadrant is 90, this would be 90, all the way here would be 180. So 150, again, we're not using protractors, we're just eyeing it up, and we're labeling it. The arrow is important because that represents it being a positive angle. And then just to make sure that there's no mistakes, I say theta is 150 degrees. I draw my bow tie triangle. So envision a little dot up here. You drop your triangle down to your x-axis, and the angle that is in the bow tie triangle by the origin is going to be your reference angle, alpha. To find alpha, you visualize what's happening. If this is 150, but all the way over here would be 180, because half a circle is 180, to get this little guy, I'm just going to do 180 minus 150, and I get 30 degrees. And remember how we said the reference angle has to be positive and less than 90? That's positive and less than 90. If they asked me for a coterminal angle to 150, I could add 360, write it down, subtract 360. I could do that forever and always. B, 315. By the way, for any of these B, C, D, you might want to pause the video, try them, and then you can just kind of check your answers. And if you get it wrong, then you can watch them all, or just keep watching, which is what I know a lot of people do. But for B, 315, first off, it's positive, so I'm going up. I know a whole circle is 360. I also know if this is 90, this is 180, here would be 270, so I'm still in this quadrant somewhere. So 315 might be something like this. You need your directional arrow, just a line to start here, an arrow at the end, and we would say theta is equal to 315 degrees. You draw your bow tie triangle, so envision a little dot up here. You always drop back down to the x-axis, and your alpha is going at the origin. And to find alpha, you just have to visualize the setup. If a whole circle is 360 and this is 315, I'm going to do 360 minus 315. Therefore, my alpha is 45 degrees, which is positive and less than 90. Negative 120. Since it's negative, I'm going down. This would be negative 90, negative 180. So negative 120 is down here somewhere. I'm going to be honest. Even if this was negative 170, I'd probably still put it here because I'm representing it with labels, so I can't argue it as long as I fall in the correct quadrant. And 9 times out of 10, we need to draw that right triangle for some type of information. So I always just give myself room to draw my bow tie triangle. So this is the negative 120. Again, you're drawing your bow tie triangle back to the x-axis. Alpha goes at that little angle that's by the origin. Now, the negative is just telling me to graph down. Now I'm ignoring the negative. That was just telling me to graph down. To get my alpha, I'm just saying, hey, if this is 120 and half a circle is 180, I'm still just doing my 180 minus 120. Still just doing the 180 minus 120. So my alpha is 60 degrees. Again, reference angle is positive and less than 90. Finally, 140. Since it's positive, I'm going up. I know 180 would be here, so 140 falls in quadrant 2. Do your labels. You need your directional arrow. You need your theta. If I asked you to draw one of these on a quiz or a test, you would get a point for your initial side, a point for your terminal side, a point for your directional arrow, a point for your label, so you can see that they will add up quickly. Draw your little bow tie triangle, put your alpha in there, and then I can see that if half a circle is 180, this part is 140, alpha will just be 180 minus 140, so I get 40 degrees. Again, positive and less than 90. The next topic is switching decimal degrees to DMS, which is degrees, minutes, seconds. Degrees, minutes, seconds is a more accurate representation of decimal degrees. So if I have something like this, 42.575 degrees, if this decimal would keep going on and on and on, and I was, say, flying a plane, I wouldn't be able to round these values, because every time you round a value, if you're flying a plane, you're going to not end up where you're supposed to be going. So like for maps and navigation and all that stuff, instead of using decimal degrees, they use this degrees, minute, second. This is just a more accurate representation of decimal degrees, so they don't have to round as much. So if you ever look at a map, you're going to see it as degrees, minutes, seconds. If you look at like the deed to your house, degrees, minutes, seconds. That's why a lot of people have to pay surveyors to come out and map out their property lines, because they don't know how to change this to decimal degrees so they can figure stuff out on their own. So degrees, minutes, seconds, as it sounds, when you think of minutes, seconds, I'm hoping you think of 60 as the magic number, because that's pretty much the most important part. We know that 360 degrees is one full revolution. For comparison's sake, 1 degree is equal to 60 minutes. So that little line there means minutes. 1 degree is 60 minutes. 1 minute is equal to 60 seconds. So seconds is that little symbol, minutes is that little symbol. But 60 is the magic number, and it basically makes a more accurate representation of a decimal value. So they want me to convert from this to decimals, and then decimals to the degrees, minute, second form. Now, when I'm converting this, 36 degrees, 25 minutes, 18 seconds, the whole number, the 36, is what I like to call the untouchable number. So at the end, this is going to be 36 point something, something, something degrees. You never start in the middle. Never start in the middle. You're always going to start at the end. And basically, I have this whole number 18, and I'm trying to change it back to a decimal. 60 is the magic number. You're either multiplying by 60 or you're dividing by 60. Common sense, if I have a whole number and I'm trying to change it to a decimal, clearly I'm going to be dividing by 60. You do 18 divided by 60, you get 0.3. So think about it. This is now a 0.3. 0.3 is attached to that